Hello. This video is basically a companion video to the previous one, which was about how to install the super secret lib 5000 Python library. This video will go over, well, it's basically just it's a giant explanation of the library functions. I hope it's easy enough to understand. It should be, hopefully. Alright, let's get started. You gotta start off with how to import it. It's pretty important if you want to use it. It's just a regular import. And what was it? Super secret lib 5000. Oh my god. Okay. 5000. This is the name of the library. And of course, this is really long to write. It's very long to write. I'm gonna shorten it. Much shorter. So this is the entire line. Don't forget as this if you want it to be short. This single line imports 4 standard libraries. This time, math, and JSON. These are very important for the stuff that goes on in the library. It also imports various Spike, like Lego education libraries, like motion sensor. It's very messy, but basically this is the gyro. It allows you to see, like it does X, Y, Z is up this way. About right. So you can see how it turns this way. I don't know, something like that. This very simple diagram is probably not even correct. Actually, yeah, roll, pitch, yaw. So, yeah. It also imports hub.light, light, and hub dot what was it, light matrix. This one is the little Bluetooth button. I don't actually know how to draw the Bluetooth symbol, but it's the tiny little button with the Bluetooth symbol in it. And this is the 5x5 grid. That is not 5x5, but you get it. It's 5x5 grid that is on the hub. You can choose a symbol for. The next one is, I've seen it already. Hub dot color and sensor. It's a dot. Whoops. Dot. It also does mode repairs. It is so. It also imports mode repairs. The next thing that you need to import for really just to run your code, because you need to do async functions, is make sure I'm writing that correctly. Good enough. Run loop is fun. It's very fun. Run loop. I probably shouldn't write that twice, but I don't need to. So, I'll probably just explain this better by example. I'm probably just able to explain this better by example. So, let's just say you want to move a motor. Let's say this is, motor A by 30, maybe 30 seconds. By 30 centimeters. Sure. Rewrite that. And then you want to move motor, let's say b, okay, of course, b by, my writing is terrible today, 90 centimeters. Without the glorious run loop, it's going to run for about 1 millisecond. It's going to switch to this immediately and run for 1 millisecond. We don't want that. So with run loop, we can add a wait into this line. Into both of these lines, actually. And it's going to run this for the full time before going to the next and running that for the full time. This is what we want, because you want the bot to be able to move as far as you tell it to, without just moving for like half a centimeter and then going to the next thing. Okay, next thing. We got the functions. There's like, I think there's like 5. Yeah, there's forward. You got forward. That's very bad forward. I don't know over here. Makes sense. There's turn. There's attachments. And there's also sensors. These are your main move. Make sure I'm actually writing an M. These are your movement functions. We also have one very special one called Init, which you basically give it a config and it loads it. Well, it has parameters that give you you can give it a config per code. You can also put one on the bot. I will be explaining that. Never mind, I already explained it. Yeah, so this is a very special one. This is the best thing. So I'm gonna go for forward. It's got, what does forward have? Forward's got like that. It has 6 full parameters. Normally you got 3 positional. You got your distance in centimeters, whether to stop or not, which is cool. You've also got run. So equals, let's just say, you might be able to guess from this what it is, but this is a lambda type. We've also got, what is this? That's my fault for writing so far away from the margin. Okay, yeah, we got assist. We also have like 3 total. There's 3 total keyword parameters, so that would include velocity, acceleration, assist. That is very bad square. 1 second. This is very special for reasons. These 2, degrees per second and degrees per second squared. This is speed over time. No, wait. Oh, it's about acceleration. 0 to 10,000. This is velocity. Default of the defaults of 360. Yeah, does that. So this, the distance, the first parameter is distance in centimeters. Let's say you have the bot, you want it to move forward 30 centimeters. It will, move forward 30 centimeters. This is not degrees, as, I don't know, for people watching this that may have experience with the Spike library, it has options for like time and degrees. We just translate it directly to centimeters here, so it's easier to measure. This one, this one, that is it's a Boolean that's like, I'm just gonna explain Booleans first, because so that this explanation will make more sense. Nope, I'm gonna rate that better. But basically, Booleans are a true or false value, and in some cases can be thought of as a question. Well, yeah, it's true or false value. Like, yeah, 1, 0. In some cases, Booleans can be thought of as a question. So in this case, since this is the stop parameter here, it's like, do we stop? Yes or no? Yes or no? Which can directly translate to true or false. That is, okay, these three parameters here are going to be explained after I explain them. They're going to be explained together. Actually, I think stop and assist are going to be explained together, actually. Okay, yeah, so that's stop, and also the distance. The next two are a bit strange. If you got, run until. This is a lambda. Lambdas are basically like callable variables. You set them to a function call. In this case, run until is supposed to be set to a sensor call, so let's make a mock one right now. Let me write that better. Alright, left. Whatever color value we want. I'm just going to say 5. Well, really, yeah, let's go 8. This is the sensor call. That is part of SSL5K. And so basically you're setting run until to whatever this is, and lambda means that it will be called whenever it is checked. So in both forward and the turn function, we have this code block that is like, if run until, it will stop. Well, probably should set it to, probably should set it to break. It'll go to the stop call after that. If you have stop set. If you have stop set to true, then it'll stop. If not, it'll just go to the next thing. But, so it'll check this. I realize now this is very unreadable. So, it'll run this, which runs that. So basically how sensor works, it checks, this port with this type of sensor for this value. Now, I'll explain that later when I actually get to explaining the sensor thing. But yeah, that's run until. It's very cool. I hope I explained it well. We've also got, gotta get to assist. So, actually what am I saying? I'm there. I'm at assist. So, just like its cousin, stop, it is a bool. Now, the thing with these, is both like do assist, do stop. Do I stop? Do I? I don't know. Yeah, I like using them as like questions. That might be how they're intended to be used. I have no idea. I actually don't know what the Python standard is. Well, what am I saying? yeah, we use them like they're basically just questions. Stop. Yeah, true. Assist. True. Yeah, false. So assist, basically, this is, I'll write that better. Assist is gyro, which is motion sensor, which is one of the things that the import statement does. It imports this, which has this, and now we can use this. It is basically just makes sure that while you're moving forwards, that your bot stays. Draw a square. While you're moving forwards, and make sure that your bot stays on track. Let's say like a lot smaller. Let's say like there's just a weird obstacle here. When it gets to there, without assist, if assist is false. Oh yeah. So let's say there's like an obstacle here, and without assist, the bot will just, not a triangle. The bot will tilt and just keep going this way for eternity. But when assist is true, it'll correct itself and it'll correct itself and keep going this way. Your bot, stays on track the entire time. That is the magic of assist. Now, the thing that I didn't mention is that both stop and assist are false by default. They're both, no stop. I'm gonna write the thing that I just said. They're both like, no stop, no assist. Stop and assist. If I can get that. Stop, assist. They're both false by default. The reason for assist is that gyro, well, we found it to be quite unreliable. Oh my god. I cannot write. Okay, no write. We found gyro to be quite unreliable. Now this basically, because of this, we don't want someone, let's say there's just like a kid here, coding with the spike prime, using our library. We don't want him to, say nothing about assist, and have it be, true, even though we didn't say anything about it. And he doesn't know why, and like, when he runs the code, his bot just kind of goes all over the place. He doesn't know why, because he didn't say anything about assist. Now, if we have assist false by default, none of this will happen. The bot will just go forwards on his merry way to wherever he told it to go. That is why we want, this is good, not good. Stop is, okay. This is, do stop, false. So don't stop in between things. So let's say you want the bot to go on a path like this. You have it going forward. It goes forward until it gets to here. It'll stop, so it can do a turn. It'll stop so it can do a turn. And then you have it stop again, so it can go forwards. This causes a lot of error. It could be pointing different directions each time because it has stopped and started, and it could be in different positions each time because it has stopped and started twice. Now, in this, I'm just going to write F for false here. So in this one, let's say true down here, you want the bot to go on the same path. It just kind of does that with a bit of slowing down here so that it can do the turn. Okay. Yeah. The bot does technically have to stop in here, but it doesn't actually stop. It doesn't actually cut out the motors. It just does the next thing. So this ends up being much more reliable with only like a few different probabilities. Those are really bad probability. With a few different things that could be happening, but they're like really close, small and close together branches. As opposed to this is very exaggerated, but like they're much more branched out than this, which is better. So next thing, which is turn. We got what was it? Yeah, turns. Turns have turns have the degrees that you want to turn. They've also got stop equals. They also have the good old run until. That is where it ends. They don't have anything else. They don't have anything else. Actually, no, they do. They have a lot. Oh my god. They have. City. This is the only KD work for that. That's the only thing. So, this degrees here is bot turning this way. So let's say this is 30. Actually, let's do 360. Let's say that's 360. Let's say that's 360. So we have it turning 360. It'll do the entire circle, like that. And then if you want to go backwards, go negative 360. It can do anything from 0 to actually any value. It'll turn that number of degrees. Stop. This is the exact same as forward. There's just a little thing with run until. When you're doing a turn, you got your sensors probably on two different sides of the bot. That's not even coloring in orange. 1 second. Yeah, you got your sensors on probably two different sides of the bot. If you don't, that's fine too. The way we have our bot set up, it looks like this. Sensors left and right, left and right on the front. When we turn, if we select the same, sensor side that the bot is turning on, so if it's turning left, you select the same left sensor side. That will activate the left. The left side will see this color before it is actually, facing this point. Let's say we want it to face that point. It'll, see this. It'll see this color before it's actually facing this point. When it's facing here. The thing that we want is when it is facing. Just color that in. Is when it is actually facing the point. That is when you want to select this sensor. We want to select this sensor. That is when we want to select this sensor. The one that is opposite the way we are turning. So if we're turning L, if we're turning left, we want to look at the right sensor. If you're turning right, we want to look at the left sensor. Unless you want this angle, which is fine. Yeah, unless you want this angle, which is fine too. I think that covers turn. We can move on now to, attachments. Probably the simplest thing in the library, or the attachment, is the attachment functions. So, attachment has two things. That would be degrees, so let's say we want to do attachment, if I wrote that correctly, 360. And the side, we can do left. This is, it accepts left, right, and both. Let's right and both. What else? what was it? Okay. Yeah, so this, the same as turn, it is degrees. Yeah, so that is like the way we have our bot set up. The bot our we have the wait. This is degrees. The way that we have our bot set up, it is has the two attachment. It has attachment motors on the top. Let's say our hub is here. This is Gary, by the way. This is Gary, one of our bots. Say hi to Gary. And it'll spin the attachment motors this way for 360 degrees. Spin them that way. Same thing applies for turn, where if you set it to a negative, they'll turn the other way. Now the only limitation with this is that you gotta do some trial and error, because let's say this is the top face of the bot. That's the motor. If you have your attachment set up so it translates horizontal to vertical, you kind of have to do that math yourself, or you gotta do, or you need to do like trial and error. I believe that covers attachments. Move on to the sensors, which I talked about earlier. For the sensors, let me just set this up real quick. Okay. For the sensors, is the type of sensor. The side. If I started writing it correctly. Left, okay. That's the side, and then, the side is left or right. There is no both. There is no both. It's just left or right. And then it's the color. The Spike API, well, the Lego Education API that is default on the bots, has like a custom color setup. I'm actually going to be showing that in the examples portion later, so you get to see that. But yeah, they have their own like colors. They have their own like color values and stuff. It's basically, I believe like 0 is black, 1 is red, and so on until you get to like 8, which I know 8 is orange, and the -1 is unknown. I'm pretty sure that's just a stand-in for white, because it can't really get a white value. This, we don't... Okay, back to the actual call here. This is the side, which I already talked about. There's also... there's also this value. That is the sensor type, and currently we only have color sensors implemented. This syntax will generally stay the same though, because this is your expected value here. It is looking for this, and it'll return true if it finds it, false if it doesn't. So you can, if you don't want to type like force, let's say you're looking for like 10 newtons of force. You can write that too. That'll work. It's just not right now because we don't have it in. Just not right now because we only have color sensors implemented. Okay, the next thing is the simple examples. On my outline here it says I'm talking about run until and stop. I don't need to do that. But yeah, so okay, the next thing is examples. Examples for like the getting started portion. See you in a little. The init function is init, and then it's just a bunch of keyword arguments actually. So you got your drive. Well, if I wrote it correctly, it would be drive, not whatever that was. Drive. This has L and R. Attach L and R. It also has sensors L and R. There's another one that's like it's It's actually all uppercase because it's meant to be a constant. So I'm just gonna write lowercase because it's easier. Wheel. Diameter, and also there's turn radius. We don't mainly use these. This tutorial uses another one that is use underscore JSON, which this is a bool. We love bools here. And this is, as the name suggests, use JSON. It is a question. Y or N? Basically, you've already seen the init.json file. This will load the init.json file. It basically gets all of these keyword parameters from it, so you can use all of the functions. Well, actually, if you do these keyword parameters in the code yourself, it does the same thing that use JSON loads, if that makes sense. So, like, let's say, actually, yeah, never mind. If that makes sense, cool. I think I've already explained most of that functionality by this point. I'm recording this before I actually record the installation portion, so that's why I don't actually know.